Here's a standard deviation question. It's slightly unusual. It's in paper 1. You don't normally get a data set and asked for a standard deviation in paper 1 where you're not allowed to use a calculator. It's also unusual in that it's got this expression a root b over 2. Now you may panic and think, I've never been taught a formula like a root b over 2 when it comes to standard deviation. Let your panic subside and let's just find the standard deviation for this set of data, and we'll see if this a root b over 2 makes sense after we've done that. So if you look at your formula sheet, 2 different formulae which will calculate the standard deviation for you. And the first one we're going to have a look at. I think we'll then do the second one and show both methods. So the first one, there's x's, x bars and n's, the sigma involved. X stands for the data values 1, 4, 6, 3, 6. X bar is the mean. In other words, you add, find the sum, that's what the sigma stands for. You find the sum of all the data values and then divide by the number of data values. In this case, there's 5. So let's add up the data values. 6, 9, 15, 19, 20. Therefore, the mean will be the sum of these data values divided by 5. 20 over 5. That's 4. So the mean of these numbers is 4. Let's look at the next part of this formula. It says x minus x bar, and then there's a squared term there. So let's have a look at x minus x bar. This is the difference between the mean and the data values. If you like, the deviation of the data values from the mean. So we've got 1 minus 4, negative 3. 4 minus 4, 0. 6 minus 4 is 2. 3 minus 4 is minus 1. 6 minus 4 is 2. Now the deviations from the mean, x minus x bar, is not what we're after. We're after these values squared. So the next column in this table, the next set of calculations, will be x minus x bar squared. So we have to square each of these. Negative 3 times negative 3 is 9. 0 times 0 is 0. 2 2's are 4. Negative 1 times negative 1 is 1. 2 times 2 is 4. All of these values should be positive. Now what do we do with these deviations from the mean once we've squared them? Well, we add them all up. So it's the sum of all these deviations from the mean squared. So the grand total here, 4, 5, 9, 18. So that's the top part of this fraction. Bottom part is n minus 1, 1 less than the number of data values. That's 5 minus 4. So I think we're set up now to calculate the standard deviation using that first formula. So we've got the sum of the squared deviations from the mean divided by 1 less than the number of data points, and we have to find the square root of that. So it's 18 over 1 less than 5, that'll be 4. And it's the square root of that. So that's square root of 18 over the square root of 4, which is 2. Now, we can begin to make sense of this. You'd now be realizing can be written as we have to write this answer, since we've no calculator, we don't give decimal approximations, we have to write this answer in this simplified form. In other words, root 18, a third, we simplify it. Remember, we think of square numbers, like 9 as a factor, 9 times 2, because we can then take the square root of each of these two numbers. Square root of 9 is 3 times the square root of 2. Taking the square root of each of these numbers and divide that by 2. So we'll now compare what we've got with what they suggested we should have, a root b over 2, and it does match with a being 3 and b being 2. And we were asked for the values of a and b. If you missed this last bit out, you wouldn't get full marks for the question. So a is 3 and b is 2. Let's do the whole process again, but using the second formula. So let's see what the second formula asks us. The sum of the squares of the data values. So we need to work out the squares of these data values. So 1 times 1, 4 4s, 6 6s, 3 3s, and 6 6s. And we need the total of these. So there's 36, 45, 81, 97, 98. Now let's move forward to this bit. This bit is the sum of all the data points, which we know, we worked that out in the first one, that's 20, and we have to square that answer. So I think we have everything here, so let's work out the standard deviation using this second form of the formula. So, first of all, the sum of the squares of the data values, we've worked that out to be 98. Subtract the sum of the data values, that's 20. So the sum of the data values squared would be 20 times 20. That's 400. Divided by n, that's the number of data values, which is 5. Then the whole thing gets divided by 1 less than the number of data values. That's 5 minus 1, that's 4. So things are progressing. We've now got the square root of 98 minus 5 into 400 is 80. 5 80s make up 400. So we end up with the square root of 18 over 4. And as before, that'll be the square root of 9 2's over the square root of 4. So it's root 9 is 3, root 2 over 2. And again, comparing with a root b over 2, a is 3, b is 2. So fortunately both formulas give us the same answer. Of course, you only need to do it one way, one of these formulas. You might be happy just doing it the first way, you might be happy using the second formula. It's entirely up to you. Lovely choice to have.